Now that we have learned 3 ways to solve systems of equations, meaning more than one equation, we learned how to solve by graphing, by substitution, where we have x or y by itself and we plug it into the other equation, or by elimination, where we add or subtract our equations together. We learned those 3 ways, and every single time we got an answer x, y. Now we're going to come across a couple special types of situations that we're not going to get an answer x, y. So we have 3 possibilities for answers. One solution would be if there are different slopes, meaning they're going to cross. So that's when we're going to get an answer x, y, because our graph, one line goes one way and one goes the other way. Wherever they cross, that's our answer, x and y. But if it's no solution, that means that the lines are parallel. Because if we have a graph and the lines are parallel, well, there's nowhere that they're going to touch, so the answer will be no solution. And then the third situation is when we have infinitely many solutions. If we are going to graph 2 lines, and I graph one line and it goes like this, and I graph another line and it turns out to be the exact same line, it's really the same line, so this has the same slope, same rise over run, and the same y-intercept. So it's really crossing at every single point. So instead of listing out all of those points, we just say there's infinitely many solutions. Or you can abbreviate and just say IMS, infinitely many solutions. Infinitely meaning there could be thousands and go on and on and on. We can't list all of the possibilities because it's infinite. And so we just write IMS instead. So we're going to first start off by reviewing what parallel looks like. So we're going to find our slope of line A, line B, and line C to determine which are parallel. And remember, this symbol, 2 lines slanted, means parallel. So first let's start with line A. A, from here to here, we're rising 1, 2, and running 1, 2. 2 divided by 2 is just 1, so our slope is 1. The second line, line B, our slope from here to here, we're rising 1, 2, and running 1, 2, 3. So that's 2 over 3. And then line C, we're going to count this slope as well. From here to here, rise 1, 2, and run 1, 2, 3. So you can see that B and C are parallel. So you can write B is parallel to C. Some of you may have been able to tell that just by looking at the graphs. However, I need you to prove, using your math skills, that they're the same by counting our slope. Then the next one, let's find the slopes for A, B, and C. So first line A right here, from here to here, we're really going down, or -1, -2, and over 1, 2, 3, 4, -2 over 4. Or we can simplify that if we divide both by 2. It's the same as -1 over 2. Then line B, from here to here. Be careful on this one now, because this point's really in the middle. Notice that's at 2.5. We're going down 1, 2, 3, and then a half would be in the middle. We went down 3.5 or 3.5, and over 1, 2, 3, 4, 5. Now if we don't want that as a fraction, to get rid of 0.5 or 1/2, we could multiply by 2 and get whole numbers. So 3.5 2 times would be 7, because 6, 3 and 3 is 6, and the halves would make 1 more. 5 times 2 is 10. So if you wanted a whole number slope, you could multiply by 2. And then line C, from here to here, there's a point under there, we just went over it. We're going down 1 and over 1, 2. So you can see, get it, C? You can see that lines A and C are the same, -1/2 and -1/2. So A is parallel to C. If you wanted to write C is parallel to A, they mean the same thing. So you just have to write it one time. So let's take a look. We have two equations. We need to solve by graphing. We're either going to figure out where they cross and list our point x, y. It's going to be no solution, maybe, meaning our lines are parallel, or having infinitely many solutions. It's the same line. So you can't just look at the equations or solve for y. You also have to graph it. Okay? So we're going to start off by solving both of these for y, so that we can graph. I'm going to write this one over here, 3x plus 2y equal to 10. I'm going to solve for y so we can graph. So we need to get rid of the 3x, so I'm going to subtract 3x. Hopefully you remember how to solve for y. We have 2y equals negative 3x, and that's a positive 10, so plus 10. And then we want y by itself, so the opposite of multiplying by 2 is divide by 2. So that makes 1y, or just y. Negative 3 over 2 is not going to make a nice number, so leave it as a fraction. Whoa, undo that. So that was y equals negative 3 over 2x plus 10 divided by 2, which is 5. I'm also going to solve the other equation for y. So I have 3x plus 2y equal to 2. So again, I need y by itself, so I'm going to move the 3x, subtract 3x. So I have 2y equals, this is a negative 3, so negative 3x plus 2. And then last, divide everything by 2 to get rid of the 2. So those eliminate. We have y equals negative 3 over 2. We can't simplify that. X plus 2 divided by 2, which is 1. So we need to graph both equations. I'm going to graph this one in red up here first. So it says y equals mx plus b. Remember, that's the form we know how to graph. So b is for begin. We're going to begin at 5. So up 1, 2, 3, 4, 5. And then our slope is negative 3 over 2. So down 3. 1, 2, 3. And over 2. Negative 3 is down 3. And over 2 to the right. Positive numbers are to the right. Down 3. And over 2. Oops, 1, 2. Down 3. And over 2. And then last, up 3, 2 to the left if we want to go the opposite direction. So there's the first line, the one that was written in red. And now we're going to graph this second one, which this one begins at positive 1. And our slope is the same, down 3 and 2 to the right. Negative 3 is down 3, 2 to the right, down 3. Or we can go up 3, 2 to the left. Up 3, 2 to the left. So hopefully you were able to tell from the equations. If you couldn't, you can definitely see from the graph now that these are not going to cross because they have the same slope. So our answer to this would be no solution. We cannot figure out what our x and y is where they cross because they don't cross. So there's no solution. Here's the next one. I was nice to you, and this one is already solved, so we can graph that one right away. I'm going to start at up 2. And my slope is rise over run, up 1 and over 2, up 1, over 2, rise 1, over 2. For the opposite, down 1, 2 to the left to create the other half of our graph. So I'm going to draw my line through that first equation, or that first graph. So that's this one. The first equation, though, we need to actually solve for y. So it says x minus 2y equals negative 4. And so this is really a 1x. I'm going to solve this by getting y by itself. That's our goal. So this 1x I need to move. It's a positive, so I need to subtract 1x. Those eliminate. I have negative 2y. write your x's first, negative 1x minus 4. And then last, the opposite of multiplying is divide, so divide by negative 2. Those eliminate, and we get y equals, hey, two negatives make a positive, so we have 1 over 2x. Again, two negatives make a positive, so 4 divided by 2 is 2. I'm going to graph this second one in red. It says start at 2, so up 1, 2. Oh, there's that. And our slope is rise 1, run 2. Up 1 over 2, up 1 over 2. And now this is why it might be helpful to have two colors, using your pencil and a colored pencil, or a pencil and a pen, so that you can show these two lines are really the same. You can see that they're the exact same equation. So if we were to draw our line through this, I would suggest drawing a line as close as you can next to it, if you're using a pencil, to show that it's really two lines. Or try and make some sort of dash next to it so that I can see that those lines are really the exact same line. But you also need to state your answer. Our answer normally is where they cross x, y. However, these cross at many points, so we're not going to list them all. Our answer is infinitely many solutions. Infinitely many solutions. Meaning that it's going to cross at a lot of points. Next, we're going to do the same thing, but we're going to do it by using elimination or substitution. We've learned both of those methods already, so it should be a review of substitution or elimination. So these ones have either no solution or infinitely many solutions. So if we get an equation that's like 5 equals 5 is our answer, well, 5 is always going to equal 5 no matter what. So that's going to be where you have like infinitely many solutions. If it's 0 equals 0, negative 5 equals negative 5, whatever the number is, that would be infinitely many solutions. It would be no solution if you get like 5 equals 8, or negative 3 equals 10, or something like that. So those are examples of when you'll have no solution, doesn't work, not possible, or infinitely many solutions. So this first one is set up to do elimination because we have our x's, our y's, and our numbers all in a row. If you look, the x's are already the same number and their opposites negative, positive, so I can just add my equations together. So 5 minus 5 is 0. 3 minus 3 is also 0, so we have nothing on the left. And on the right we have 6 plus 3, which is 9. Is 0 ever going to equal 9? Well, no. That's not possible. That's no solution. Meaning, if we were to graph these, they would be parallel lines because they're not going to cross. It's not going to work. Let's try the next one. This one is set up nicely to substitute. Meaning we're going to take whatever y is equal to, and we're going to plug it in the other equation for y. If you wanted to get x and y on the same side and then multiply to use elimination, you could, but it's more work. So I'm going to substitute. I'm going to write this second equation, negative 6x plus 3y, but y is really equal to 2x minus 4, all equal to negative 12. So let's do a little distributing first. 3 times 2x is 6x. 3 times negative 4 is negative 12. And we have this negative 6x over here as well. So if we simplify, we can combine some like terms. Negative 6 and a positive 6, well, that makes 0, so those eliminate. So we have negative 12 equal to negative 12. Well, yes, negative 12 is always going to equal negative 12. Just like one of these solutions here, this one is infinitely many solutions. Meaning that if we were to graph it, it would be two lines that are exactly the same. No matter what you plug in for x and y here, negative 12 is always going to equal negative 12. Alright, these ones, you get to decide what method you would like to use. You can use elimination or substitution. I would suggest not using graphing because I didn't provide you with a graph. So it's going to have either one solution, meaning that you're going to have an answer x comma y. It doesn't ask you to find it though. It says, without solving, tell whether it has one solution, no solutions, or infinitely many solutions. So if you figure out what x is in an equation, let's say x equals 2, you don't have to plug it back in. You can just write one solution. It's not asking you what it is, it's asking you how many solutions are there. Identify the number of solutions. So this one's set up really nicely to do elimination. X's, Y's, numbers. We can get rid of the X's or the Y's, however they're all positives. So instead of adding, I'm going to subtract. If I subtract this 6, I also have to subtract here and subtract here, but that makes a positive. So 6 minus 6 is 0. 2 minus 2 is also 0. So we have nothing. There's no X's and no Y's. They eliminated. And then 3 plus 5 is 8. Well, 0 is never going to equal 8, so this is no solution. Let's move on to the next one. This one's also set up to eliminate. Our X's are different numbers. Our Y's are the same, however, they're all negatives. So instead of adding, I'm going to subtract. This subtraction then becomes a positive, and this subtraction also becomes a positive. So I'm going to put a 1 here, because this is really 1x. So 1 minus 2 is a negative 1x. 3 minus 3 eliminates. And then negative 15 plus 18, there's more positives. 18 minus 15 is 3. So then the opposite of multiplying is divide. Divide by negative 1. And we know x is a negative 3. So this tells us we could figure out what x and y are. We already know what x is. But you don't have to plug it in. They just want to know how many solutions are there, and we know there is one solution. Meaning these two lines would cross at one point. X, y, whatever that is. Our third question here is also set up for elimination, so all of these ones used elimination. Our x's and our y's are not the same number. I'm going to maybe get rid of our y's because they're small numbers here. I can multiply this top equation by 2 so that this is a positive 2y and this is a negative 2y. So let's distribute that. I'm just going to write the equation underneath here. It's going to read 2 times 5, which is 10x, 2 times y, which is 2y, and then 2 times negative 2, which is negative 4. So now I don't need that top equation. I have just these bottom two, which I can add or subtract. The y's are already opposite, negative, positive, so let's add our equations together. Negative 10 plus 10, oh, those eliminate as well. So negative 2 plus 2, oh, gone, we have nothing. And then 4 minus 4, oh, that's also gone. 0 does equal 0, so this is not no solution, it's really infinitely many solutions. Because 0 is always going to equal 0. These lines would be exactly the same. Alright, here are 3 more that I would suggest you try at least this first one on your own. Solve using substitution or elimination. So go ahead, try this first one, and then we'll go through the other 2 together. So this is ready to eliminate x's, y's numbers, and the x's are also ready, one positive, one negative. So we can add these up. 1 minus 1 is 0. Negative 2 plus 2 also is 0. So we have 0 equals 7 plus 7, which is 14. Well, 0 does not equal 14, so this is no solution. This next one is actually set up to do substitution. We have y all by itself, so I'm going to substitute that in for the letter y. So when I write this top equation, it says 5x minus 5y, but y is really x plus 0.6, all equal to a negative 3. So let's distribute, get rid of our parentheses. Negative 5 times x is negative 5x. Negative 5 times 0.6, I know it's going to be a negative, and I'm just going to plug that in my calculator. 5 times 0.6 will give me 3, so it's a negative 3 equals negative 3. Don't forget this 5x over in the front there. So we want to get x by itself, so first let's combine our x's. 5 minus 5, oh, those are opposites, they eliminate. 5x minus 5x is nothing, there's no x's left, so you can't write an x. We simply have negative 3 equal to negative 3. Well, negative 3 does equal negative 3, so this is infinitely many solutions. It's true, this works. It's the same line if we were to graph it. So our third one, this is also set up to do substitution. So I'm going to plug this in for the letter x in the first equation. So we have 4y plus 5x, and x is really 8y plus 3, all equal to 15. So let's distribute. We have 4y there. 8 times 5 is 40, so we have 40y, plus 5 times 3, which is 15, equal to 15. So combine your like terms. We have 4y plus 40y, that's 44y, plus 15 equals 15. And our goal is to get y by itself, so the opposite of adding 15 would be subtracting 15. So we have 44y equals, well, that gives us 0. And then get y by itself, I'm going to divide by 44. So we have y equals, well, 0 divided by anything is just 0. So I know that this is going to have an answer x comma y. I already know what y is. I don't need to keep going. It's just asking how many solutions there are. And there is only one solution. It's not asking you what it is. It just says solve using, oh, I lied. This one does say solve. It didn't say determine the number of solutions. So we would have to solve this one to figure out what x is as well. So I know y is 0. I'm going to plug it back in to this the second equation. It says x equals 8y, which is 0, plus 3. Well, it's really not that much extra. 8 times 0 is 0. So 0 plus 3 is 3. So that would be our answer, our one solution that we have. All right, here's last two like this, and then we'll do one word problem. So I would suggest you try these on your own, and then click play to check to see that you got them correct. We're doing many like this. This also serves as a good review for you a couple days before your test. So, substitution or elimination. This one's set up nicely to eliminate x's, y's numbers. And our y's are already opposites, negative and positive. So let's simply just add our equations together. This is a 1x, so 3 plus 1 is 4x. Negative 2 plus 2 makes 0. 24 plus 8 should give us 32. I'm going too quickly, please make sure to pause. And then divide by 4. So we have x equals, well, 32 divided by 4 should give us 8. It actually says solve, so we need our answer in the form xy. So we know x is 8. I'm going to use this second equation because it has smaller numbers and x is already by itself right here. It's just 8. Plus 2y equals 8. So if I solve this one, subtract 8, we get 2y equal to, well, 8 minus 8 is 0. And divide by 2, y is still 0. So our answer, where these two lines would cross, is 8, 0. last one like this. This is also set up nice for elimination, so I'm going to add or subtract these together. However, the x's are different numbers and the y's are different numbers. I'm going to get rid of the y's. If I multiply this top equation by 2, they should both be a 4. So multiply the top equation by 2. Multiply every single term. I'm just going to write it right below so we can easily add our equations together in a minute. 2 times 3 is 6x. 2 times 2 is 4y. And 2 times 4 is 8. So now I don't need that top equation. I'm just going to add these two together. They're already opposites, negative, positive, and as it turns out, the x's are going to go away as well, because negative 6 plus 6 is 0, that's 0, and negative 8 plus 8 is also 0. 0 does equal 0, so this answer is infinitely many solutions. These would be the exact same line if you were to graph them. Alright, our last question. This is a word problem using exactly the same information that we've been working on today. It says write and solve a system of linear equations, meaning we're going to have two equations. So it says an artist wants to sell prints of her paintings. Cool, don't need that information though. She orders a set of prints for each of her 2 paintings. Each set contains regular prints and glossy prints, as shown in the table. Find the cost of one glossy print. So this was important. She orders a set of prints of each of her 2 paintings. So this is one painting. She got 45 regular and 30 glossy for this much. And this is the other set or other painting. She got 15 of one and 10 of the other for $155. We need to find the cost of one glossy print, so this one. So it doesn't tell you much, so I'm just going to say this represents x and this represents y, and we're going to write 2 equations. So the first one, in purple here, we have 45 of x, the regular print, plus we got 30 of y, the glossy print, for a total of $465. The second set of prints that she got 15 of the regular x, plus 10 of y, for a total of $155. So this is set up nicely already to use elimination, but we don't have the same numbers. To me, 10 is we can multiply by 3 to get 30, or we could multiply 15 by 3 to get 45. So I'm going to multiply all of those out. So 3 times 15 is 45x. 3 times 10 is 30y. Oops, one thing I forgot. These are both positive, so we need one of them to be a negative. So this would be a negative 45 and a negative 30. So we're multiplying by a negative. Equal to a negative 155 times 3. Well, 5 times 3 is 15. 5 times 3 is 15 again, plus 1 more is 16. 3 times 1 is 3, so 1 more is 4. So that's negative 465. So I don't need that equation anymore. I multiplied it by 3. So we can just add these 2 equations together. If you can add it just like it is, that's fine. I'm going to rewrite this one right below. So let's add these up. Negative 45 plus 45 is 0. Negative 30 plus 30 is also 0. Negative 465 plus a positive 465 also equals 0. So can we figure out the cost? X's and Y's eliminated. So in this case, this is really infinitely many solutions. So there is not enough information. We cannot figure out the cost because they both eliminated. So they gave us just multiples of the same set of information we can't figure out. We could guess, but your answer would be that there's not enough information to solve. So as a review, one solution is where our two lines intersect or cross. No solution is when the lines are parallel, meaning they have the same slope and the same or different y-intercepts. They're crossing at the y-axis at different points here. And infinitely many solutions, or IMS, is the lines are coinciding. They coincide, meaning one line is exactly the same as another. Same slope, same y-intercept. Alright, your homework is a worksheet. So go ahead and get started. These first three are matching, so be careful. These ones, you get to solve for y and graph them. If you want to solve for y in a separate sheet of paper, that's fine. And then tell me how many solutions are there. Same thing on this next page. These ones say solve, so if you can solve it. Down here it says without solving. Tell me just how many solutions there are. So meaning if you get x equals 5, don't keep solving it, just tell me that's one solution. Okay? And then these last two. This one is very similar to the one that we just did, as well as this. There are two sets of information that go this way. Okay? Good luck.